Hello friends, welcome to Susan and John MathTube. In this video, we learn how to solve homogeneous differential equations. Okay, first of all, I'll give you the format of the equation. So, a homogeneous differential equation in two variables x and y will be in the form dy by dx is equal to f of xy by g of xy, where both f and g are functions in x and y, and the degree of f and the degree of g will be same. Or sometimes they manipulate this a little bit and they put it in the form dy by dx equal to function in y by x. So remember, in your question paper, the homogeneous differential equation will appear in this format or in this format. Okay, now talking about degree. First of all, let me tell you one thing. The word term stands for separation by plus or minus. Okay, so when you check the degree, I want you to check the degree term by term. Okay, I'll give you one example. Y square minus x square, the whole divided by 2 into xy. If you look at the numerator, you can see that there are two terms, term 1 and term 2. And in the denominator, we have only one term. Okay, the degree of term 1 is 2, degree of term 2 is 2, so it has uniform, homogeneous degree, uniform degree in the numerator. In the denominator, there is only one term, but that term is made up of products. So 2 is a constant. Now look at the variables x and y. You add the power, that will be the degree. I'll give you another example. X cube plus x square into y plus x into y square plus y cube, the whole divided by x cube minus y cube. In the numerator, there are four terms. Degree 3, degree is 2 plus 1, that is 3, degree is 1 plus 2, that is 3, and degree is 3. Denominator also term by term, the degree is 3. So basically, this is a homogeneous expression in x and y. Now I'll show you something else. Suppose we have a homogeneous expression in x and y. Look, degree 1, degree 1, degree 1. If I perform division, look, x by x will give me 1 and the remaining part is y by x. And this is actually a function in y by x. Wait a minute, think about this. Can I call t square plus 2t plus 7 to be a function in t? Yes or no? Yes. This is a function in t. Suppose I write u cube plus sine 3 into u is equal to 7. This whole expression, okay, I'll take it to the other side. This can be called as a function in u. Similarly, if you do some construction, for example, 1 plus sine y by x plus y by x the whole square, you can call this as a function in y by x. I hope you understood that fact. Yeah, okay. Now, I'll show you another expression. Y square plus x square by y square minus x square. See, degree 2, degree 2, degree 2, degree 2. Divide throughout by x square, you'll see the magic again. Y by x the whole square plus 1 by y by x the whole square minus 1, which is a function in y by x. Now for the last time, let's make the standard format very clear. So how do you recognize a homogeneous differential equation? A differential equation which can be written in the form dy by dx equal to f by g, where both f and g have the same degree, term upon term, or an equation which can be written in the form dy by dx is equal to function in y by x is called homogeneous differential equation. Okay, now look at this. To solve a homogeneous differential equation, the method is very easy. All you do is you will put y by x is equal to v. That is, y is equal to v into x. I'll do a little bit of coloring. I'm doing that coloring so that students will recognize product rule. I want it to differentiate with respect to x. So v into 1 plus x into dv by dx. Now look at this. Once you plug in this like what you call y by x as v and dy by dx as this stuff, and if you simplify, I can guarantee something from my side. The simplified equation will be variable separable. Okay, now let's try to understand by working out one problem. Okay, please write the question. Solve dy by dx equal to y square minus x square by 2xy. So you can look at the right hand side. Every term in the numerator and the denominator has the same degree. So you can be 100% sure it is homogeneous equation. Once you are sure that it's homogeneous equation, in almost every problem you put y by x is equal to v. There are some exceptions. In some problems people put x by y is equal to v, like what you call, you'll be able to understand such problems by just looking at the question. Anyway, let's not make things complicated right now. So in most of the problems the substitution will be putting y by x is equal to v. That is, y is equal to v into x, so that we get dy by dx is equal to v into 1 plus x into dv by dx. So you plug in that value over here, and you can plug in y is equal to vx, 2x into vx. So we get x into dv by dx. You can see that this x square will come outside, cancel each other. So we get v square minus 1 by 2v, and I took this v to the right hand side, minus v. Now look at this. There is a guarantee from my side that I will repeat again. Once you plug in all these stuff, our y will disappear and the equation will reduce into a variable separable equation. But you have to simplify, you have to keep on simplify, and I cannot give any guarantee about the number of steps that will take you to reach that variable separable format, but you can be 100% sure that this equation can be reduced into variable separable format. So x into dv by dx, you can take LCM, so it will be v square minus 1 minus 2v square by 2v. So simplifying this, we get 2v by v square plus 1 dv is equal to 1 by x dx, and there is a negative. Okay, I'll explain. So tell me what will happen to the numerator. The numerator will become minus v square minus 1. So it took minus common, and that is that negative here, and I made it variable separable. Okay, in class 11 or in class 12 you might have learned 3-4 standard integration format, and one of the standard format is the derivative of the denominator being the numerator, and its integration will be log x to the base c, that is natural logarithm, of the denominator. Okay, one of the best example is denominator is sin x and the numerator is the derivative cos x. So you can directly write the integration log of sin x. That is, the integration of cot x is log sin x. Now another example is right in front of our eyes. What is the derivative of v square plus 1? Isn't it 2 into v? So the integration goes like log v square plus 1 is equal to minus log x plus log c. Okay, let me make you one thing very clear. Look at this. I have gone through many Naples books, and in most of the Naples books they use log in calculus with the understanding log stands for log to the base e. So in most of the Naples books the assumption is when we learn calculus, log stands for log to the base e. But let me make you one thing very clear. You can take a look at your calculator, or you can take any book which is in circulation in US or in the UK, etc., etc. They have a different system, slightly different than others. Especially for the last 10 years, it's like what you call, most of the people have started using this in most of the books also. The modern authors have changed. So what they do is, whenever they want to express log x to the base e, they simply write natural logarithm of x. They put the symbol ln x. You can see that button in your calculator. And whenever they want to express log x to the base 10, they write log x. And I am also following this particular system here. So when I write ln, don't get surprised, it is nothing but log x to the base c. Anyway, to follow or not to follow is your wish. So remember, ln x simply means log x to the base e. And when you write log x, it actually means log x to the base 10 by default. It is called common logarithm, and this is called natural logarithm. Okay, so this is ln v square plus 1 is equal to what is log a minus log b? Log a by b. Now what we do is we take inverse on both sides. And remember, log, the inverse is exponential function. So we get v square plus 1 is equal to c by x. That is y square by x square. Do you remember what is v? In the beginning we wrote v as y by x. So v square will be y square by x square plus 1 is equal to c by x. Now multiplying throughout by x square, we get y square plus x square is equal to c into x. Okay, now let's go for the next question. Solve the differential equation dy by dx is equal to y by x plus tan of y by x. So I want you to have a very clear idea about this problem. This is homogeneous. Are you able to see dy by dx on the left? And if you notice the right hand side, you will be able to see a function which is made up of y by x. Do you still remember? That is how we started today's class. Yeah, okay. So look at this. The standard equation may look like this or like this. Okay, so let's solve the problem. So you identified it is homogeneous. So you put y by x is equal to v. That is, y is equal to v into x. So dy by dx will be v into 1. Now let's plug in here. So we get, I can be very happy. I told you, once you plug in that y is equal to vx and stuff, our equation will be reduced into variable separable form. Sometimes you don't have to simplify too much. Sometimes you'll have to simplify a lot. That depends. Now let's cross multiply. 1 by tan v dv integrating. What is 1 by tan v? Okay, cot v. The integration is log sin v is equal to log x. You can write log, no problem with that. But always understand, in calculus when you write logarithm, you are assuming that the base is e. What is log a plus log b? Now let's take exponential function on both sides. So sin v is equal to cx. That is the final answer. What is v? Y by x. Okay, let's solve one more problem. That's also very easy. Solve dy by dx equal to y by x minus sin square y by x. So what should we do? Are you able to understand? Dy by dx is given to be a function in y by x. I hope you are able to understand that part. Dy by dx is given to be a function in y by x. So you identified it's a homogeneous function. Put y by x equal to v. That is y is equal to v into x. So that dy by dx will be v into 1 plus x into dv by dx. So this will get cancelled. So 1 by minus sin square v dv. I told you some problems will be like very easy, and like in one step it becomes variable separable. But in some problems you'll have to write a lot and you'll have to do a lot of manipulation. That depends. We cannot have any rule which will suggest how many steps it will take. By the way, what is 1 by sin square? Cosec square. What is the derivative of cot? Differentiation of cot is cosec square. Yeah, minus cosec square. So integration of minus cosec square will be cot. Yep, that's it. 1 by x dx. So we are almost ready. So integrating, we get cot v is equal to ln x plus ln c. No need to put ln c, there is no advantage because ln x plus c. That is cot y by x is equal to ln x plus c. So that's more than enough. Now let's go for the next question. So we have solve dy by dx plus 3xy plus y square by x square plus xy is equal to 0. Okay, now look at this. First of all, I didn't like the given equation because it's not in the standard format. The standard format that I taught you is dy by dx is equal to format. So changing into the standard format. Now look at this. Obviously this is homogeneous. Degree 2, degree 2, degree 2, degree 2. So you can start with the procedure. Put y by x equal to v, that is y is equal to vx, that is dy by dx gives you v into 1 plus x into dv by dx. We can plug in all those things. V plus x dv by dx is equal to minus 3x vx plus v square x square the whole divided by x square plus x into vx. So v plus x into dv by dx is equal to minus, you know what's going to happen because this x square, x square, x square, x square is going to get cancelled. So remaining part will be 3v plus v square by 1 plus v. And we can take this v from here to the other side, that will be still minus v. So plus v, and we'll take minus common. And I hope those who are watching this video, you're also practicing along with me. Now look at this. When you watch these videos, you'll get a very clear idea how to tackle these problems. But always remember, watching these videos will not give you marks. If you want marks, as a student, you have to practice a lot. These 3 or 4 problems will not be enough. And okay, you might be thinking it's almost you're almost near to the exam. Don't worry. I have an option. I have a suggestion. Like, you watch these videos, understand the concept, and then take your past paper questions and try to work out the problems from your past year question papers. And if you have more time, you take any book you like, any reference book you like, and again practice a few questions, a few worked out questions. But don't do it mechanically or don't copy it from your book. Try to do it by yourself. If you get time to do it, definitely you will be very successful in solving the problems in your examination. Okay, anyway, let's continue. Let's take LCM. X dv by dx is equal to minus 3v plus v square plus v into 1 plus v. So by 1 plus v. Okay, I'm going to skip a lot of steps. I hope you will reach the same plus 1 plus v by v square plus v square 2v square 4v dv is equal to minus 1 by x dx. Great. We have 1 plus v by 2 will come common. I'll take that outside. 2v into 1 plus 2v. V square plus 2v 1 plus 2v dv is equal to minus integral 1 by x dx. Okay, now look at this. We have to use partial fraction here, but I have a suggestion for you. Look at this. There's a really awesome method called method of suppression. For example, you have an expression where the denominator is in factor form. Of course, that is compulsory. The denominator should be in factor form. And every factor should be having whole power 1. So let me keep some conditions here so that you can apply the method of suppression. Degree of numerator should be less than degree of denominator. That is obvious here, because denominator is a quadratic, numerator is a linear. Second thing, the denominator should be in factor form, where every factor will have order 1. Now look at this. In partial fraction, what you do is you will write, let it be equal to a by x plus 1 plus b by x minus 4. I am sure about that. But in method of suppression, you don't write a and b, you just write it like this. Now comes the awesome part. Tell me, when will x plus 1 vanish? Vanishing means becoming 0. Oh, when x is equal to minus 1. Now what you do is, you plug in x equal to minus 1 everywhere other than x plus 1. That is we suppress x plus 1 and plug in the value. So what is 3 into minus 1? Minus 3. Minus 1 minus 4, minus 5. That will be minus 2 by minus 5, 2 by 5. Okay, now tell me, when will our x minus 4 vanish? Of course, x minus 4 will become 0 if x equal to 4. Now what you do is you suppress x minus 4 and plug in x equal to 4 everywhere other than the suppressed quantity. So 3 into 4, 12 plus 1 by 4 plus 1, 13 by 5. Okay, I'll give you one more example. 3v square plus 1 by v into v plus 1 into v minus 2. So the conditions are correct. Degree of numerator is 2, degree of denominator is 3 because it's a cubic, like what you call, there are 3 factors of power 1. So what should we do? Instead of writing a by, we write by v plus 1 whole divided by v minus 2. Okay, now tell me, when will the first factor vanish? Of course, when v equal to 0. Plug it everywhere other than v. So 0 plus 1, 0 plus 1, 0 minus 2. That's it. Now tell me, when will v plus 1 vanish? Of course, when v is equal to minus 1. So plug it everywhere other than v plus 1. So minus 1 the whole square, 3 plus 1, 4, minus 1 multiplied by minus 1 minus 2 minus 3, 4 by 3. Now tell me, when will our v minus 2 vanish? When v equal to 2. So 3 into 4, 12, 12 plus 1, 13. Then 2 into 2 plus 1. That will be 3 into 6, 13 by 6. Okay, I hope you got the point. Now let's go back. So look at this. Since you understood the method, I'm going to write this as by v plus by 1 plus 2 is equal to minus. Okay, now let's do our awesome trick. So when will our v become 0? V becomes 0. So 1 plus 0 by 1 plus 0. I think we have a mistake here. We took that common part wrong. So I wanted to correct it now. So it's like 2v is common. So v plus 2. A very good lesson for everyone not to skip steps. I skipped steps. I made this mistake. So please correct it. This will be v into v plus 2. Yeah. Anyway, let's continue. So tell me, when will v become 0? When v becomes 0. So suppress our v, 1 plus 0 by 0 plus 2, 1 by 2. When will our v plus 2 become 0? When v is equal to minus 2. So 1 minus 2 by minus 2, that will be 1 by 2 again. Okay, that's it. Integration 1 by 2 comes common, so 1 by 4. 1 by v is ln v plus ln v plus 2 is equal to minus ln x plus ln c. Now that is 1 by 4 into, what is log a plus log b? Log a into b is equal to, what is log a minus log b? We can cross multiply here. I'll take this 4 to this side, and you know that this 4 will jump here. So don't skip steps in your examination. Okay, so you're going to get v into v plus 2 is equal to c to the power 4 by x to the power 4. By the way, c to the power 4 is some other constant, so I'm just putting it as c. That's it. So we get x power 4. What is v, do you remember? Yeah, y by x. And then again y by x plus 2 is equal to c. So x power 4 y by x into y plus 2x by x so our answer is x square into y plus 2x is equal to c. Okay, now let's do one more problem and that will be the last. So please write, solve the differential equation x into dy minus y into dx is equal to root under x square plus y square into dx. Now look at this. I'm 100% confident this is homogeneous because you can look at the degree. Degree is 1, degree is 1, and this square comes inside a radical sign, so the degree is 1. But this is not in the standard form, so I'm planning to divide throughout by dx. Once I do that, I can see that I get something like x into dy by dx is equal to y plus root under x square plus y square. Okay, I can cancel this or cross multiply. Okay, wow. Now what should I do? Now I am confident that this is homogeneous. So I put y by x is equal to v, that is y is equal to v into x, so that dy by dx will be v into 1 plus x into dv by dx. Now look at this, v plus x into dv by dx. So y becomes v into x, root under x square plus y becomes v into x. So v plus x into dv by dx. Can you see this x square comes common and it comes outside the square root as x? Come on, it will be root under x square into something. When it jumps outside the square root, it will become x. And can you see every term has x? So we are going to get 1 plus v square eventually. Those who did not understand, please write more steps and try to understand. Anyway, it's variable separable. 1 by root under 1 plus v square is equal to 1 by x dx as usual. Integrate. I hope you know the formula. This is natural logarithm v plus root under 1 plus v square is equal to ln x plus ln c as usual. So you can combine this. I'm not writing that step. 1 plus v square is equal to cx. Now change over to y by x. Now you can multiply throughout by x, so you get is equal to cx. If you want, you can stop with this, or if you want to simplify further, we have okay, if you want, you can stop here again. Otherwise, you can simplify like y square plus c square x power 4 minus 2 x square y into c is equal to x square plus y square. Y will get cancelled and you can write this as the final answer. Okay, so that's it. In the next video, I'll be doing reducible to homogeneous, and that's very important, and that's one of the most lengthiest problem in differential equation. So we will meet very soon. So till then, my friends, bye.